Number 31, a ball of mass m is fastened to a string. The ball is given an initial speed at the lowest point that is enough to move it in a vertical circle of radius r, with the other end of the string held fixed, assuming that there is no air resistance. The difference between the string's tension at the bottom and at the top. So we want to find out the difference. Tension bottom versus tension top. Free body diagram. mg down. Tension up. Acceleration up. At the top, we have mg down, tension down, and acceleration pointing down. So if we look at the top first, and sum up the forces, it would be mass times acceleration, and since the acceleration is pointing down, it would be negative ma. We have negative mg, negative tension force equals negative ma, multiplied by -1 on both sides, mg plus tension equals ma, tension equals ma minus mg, and that's the tension at the top. Let's go for tension at the bottom. So at the bottom. So summation of forces, this time it's a positive acceleration. Tension up. Tension up minus mg equals ma. Tension equals ma plus mg. All right, so if we're spinning around in a circle and we have just enough of a velocity to get over the top of the circle, we could say down here that tension at the top equals m times v squared over r minus mg. And if we have just enough velocity to get over the top, the tension at the top is just going to be equal to negative mg because the velocity will be 0. So the tension at the top is negative mg. Now at the bottom, it's a little bit different story. We can use conservation of energy and see what happens to the velocity by setting gp at the top equals ke at the bottom. Cancel out the masses. The velocity is going to be equal to the square root of 2gh. This is at the bottom. So we can say, all right, let's put in v squared over r for the acceleration. And for v, we could put in this value, which is square root of 2gh squared over r plus mg. And the height that we would be comparing against from top to bottom would be 2r. So let's change that. T equals m times the square root of 2 times g times 2r. We have to square that whole thing all over r plus mg. So the 2g, 2r has to be squared. So the radical goes away, so that would be 4gr over r plus mg. The r's would cancel. So we have 4mg plus mg. The tension at the bottom is 5mg. So if we go back to this equation, tension at the bottom is 5mg, and we have to subtract minus 1 mg. It's going to be 6 mg.